These are notes for Chapter 6, Section 1, Exponent Properties. And we are going to use exponents to move us from Algebra 1 into Algebra 2, as you'll see in Chapter 7. But first, we have to have an understanding of exponents. And exponents aren't a new topic. It is a pre-algebra topic discussed 7th, 8th, early freshman year, 9th grade, in terms of order of operations. Order of operations, parentheses, exponents, multiply, divide, add, subtract, PIMDAS. Please excuse my dear Aunt Sally. So it's not that exponents are a new topic, it's that we're going to expand on what we can do with exponents or how they operate in math. And so we are focusing Chapter 6, Section 1 on exponents. And to define some exponents, there are some basic rules about exponents. We have a base, that is the big number, a base, and the exponent represents the power that the number is being raised to. So the exponent is the power. So you could say that this is 3 to the 4th power. Some interchangeable words here, exponent and power. 3 to the 4th power. 3 to the 4th power means you're multiplying 3 times 3 times 3 times 3. That's 3 times 3 times 3 times 3. Again, this is some pre-algebra topic. We should have some understanding about this already. And we can multiply. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So you could say 3 to the 4th power is 81. And so what we can do is turn this from exponential form, write it with an exponent, to product form, write it as a multiplication problem. So 2 to the 5th could be 2 times 2 times 2 times 2 times 2. 2 to the 5th. There are 5 2's. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 2 to the 5th is 32. 3 squared, or 3 to the 2nd. 3 squared. There are 2 3's. 3 times 3, well, that's 9. 5 to the 3rd. 5 times 5 times 5. There are 3 5's. 5 to the 3rd. 5 times 5 is 25. 25 times 5 is 125. And then x to the 4th, well, there are 4 of them. X times x times x times x. 1, 2, 3, 4. I can't multiply that out. I don't know the value of x, so the value you could just say is x to the 4th. And it's this real basic understanding that actually gets us our first property of exponents, the product property. So if I come down here and do the same kind of thing, product form, again, exponential form, 8 squared, 8 to the 5th. So that's exponential form. If I were to write that out, I would have 2 8s. 8 times 8. 8 times 8. If I were to write out 8 to the 5th, there would be 5 of them. 1, 2, 3, 4, 5. Now, when we're talking about larger exponents, at this point, it would be useful to grab a calculator. I'm not sure how far I could get. 8 times 8 is 64. 64 times 8 is 512 or something. I don't know. And then 512 times 8 is 4,096, maybe. I don't know. 4,096 times 8 is 32,000 something. I don't know these numbers. I'd be surprised if I got the first two right. Maybe. So instead of writing this out as the value, we just change it into exponential form. Well, I could simply count up how many 8s are there. 1, 2, 3, 4, 5, 6, 7. There are 7 8s. So I could say 8 to the 7th. Okay, let's look at a couple more here, and then we'll talk about the rule or the property that's going to shorthand these problems for us. On our second one, x to the 3rd. Well, that would be 3 of them. 1, 2, 3. Times x. Would be another one, times x squared. That'd be 2 more, x times x. And again, we don't know the value of x, so we don't actually get a value. But if I counted up my x's here, that's 1, 2, 3, 4, 5, 6. X to the 6th. And the last one here, 10 squared, that would be 10 times 10. There's 2 10s. 10 to the 3rd, that would be 3 more of those. 1, 2, 3. So now if I counted up my 10s, 1, 2, 3, 4, 5, that's 10 to the 5th. So our first rule, the product property of exponents, is a simplified way to get from here all the way to here without having to write out all of the 8's. So do we see a way that I could get from x to the third times x squared without writing actually all of them out to end up over here? And again, last one, 10 squared, 10 to the third. How could I skip all of this and end up here? Well, how could I end up with 7? 2 plus 5. How could I end up with 6? Well, that could be 3 plus 1 plus 1 plus 2. And then 10 squared and 10 to the third. That could be 2 plus 3 would give me 10 to the fifth. And so our first rule is if we multiply by the same base, 8 and 8, x and x, 10, 10, then I can add the exponents. And this makes sense if I just simply write out all of the problems. Well, yeah, no kidding. You could just add them up. That's how we got our answer. That's the first rule. If you multiply by the same base, add the exponents. So if I come down here and work through a couple of them, on number 12, 4 to the third, 4 squared, add the exponents. 4 to the fifth. 5 to the fourth times 5 to the first times 5 to the fourth would be 5 to the ninth. Add the exponents. This would be 6 to the seventh. This would be 1 to the 5, 6, 7, 11th. And of course, 1 to the 11th, you could just write as 1 because 1 times 1 times 1 times 1 times 1 times 1 times 1 is just 1. So all I'm doing is I'm looking at my exponents because all of my bases are the same, 3, 3, and 3. And I add my exponents. 1 plus 2 is 3, 3 plus 3 is 6. So 3 to the 6th. And again, the reason I can do this is if I were to write this out in product form, that's 3 times 3 squared times 3 to the third. And I were to count up how many 3's I see, that would be 3 to the 6th. There are 6 of them, 1, 2, 3, 4, 5, 6. So instead of writing them out, I could just add the exponents. That gets us to our second property, which is the power property of exponents.
Attention students, at the sound of the bell, you will be going to your third hour final. Sound of the bell, third hour final.
I'm making this during third hour final. The power property of exponents. And again, we're going to go back to writing it as product form. I have a power, 8 squared, raised to another power, 8 squared raised to the fifth. Well, if I were to write this out, I would have 5 8 squareds. I would have an 8 squared, and I have 5 of them, times 8 squared, times 8 squared, times 8 squared, times 8 squared. I have 5 of them. How do I know I have 5? Because that's what the exponent tells me. I have 5 8 squareds. So if I were to use the previous rule, if I multiply by the same base, I can add the exponents. Well, that's 8 to the 10th because 2 plus 2 plus 2 plus 2 plus 2 is 10. So 8 to the 10th. X to the third squared. I have 2 x to the thirds. X to the third times x to the third. And again, if I were to use the previous rule, multiply by the same base, add the exponents. That'd be x to the sixth. And again, 4 to the fifth to the third. I have 3 4 to the fifths. 4 to the fifth times 4 to the fifth times 4 to the fifth. There's 3 of them. And again, the previous rule, multiply by the same base, add the exponents. 4 to the 14th. Now this power property of exponents is such a shortcut. It's how exponents operate. How can I get from here without writing down all of the product form to end up here? Because I know I can add add all of them, but is there a way that I can combine 2 and 5 to make 10? We can multiply. 2 times 5 is 10. And we see this on all 3 examples. 3 times 2, if I were to multiply 3 times 2, that would give me x to the 6th. 5 times 3, 4 to the 5th to the 3rd. If I multiplied 5 times 3, that would give me 4 to the 15th. So the rule is if you have one power, a power here, raised to another power, a power here, power to a power, we can multiply. You could write them all out, but a more efficient way would be to just multiply the exponents. So if I come down here and do a couple of examples, on number 22, again, I have a power raised to a power. I can multiply 4 to the 6th. A power raised to the power, I can multiply 5 to the 16th. A power raised to a power, 6 to the 10th. A power raised to the power, that's 1 to the 12th. And if you're unsure about this, you can always just go back to the very first way that we did them, which is to write it out in exponent form. And in fact, I'll do that. I'll skip down here on number 27. X to the 4th to the 7th would be x to the 28th. I have 7 x to the 4th. And this is why we would like a little bit of a shortcut, because if I were to write all of these out, it's going to take me a second. Maybe you want to fast forward through this section. 1, 2, 3, 4, 5, 6, 7. I picked the wrong one to show my example on. And then if I wanted to even expand on it further, I could write out x, 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 and then count them all up. You can see how long that problem would get. Or you can just multiply. Y to the 1st to the 4th, y to the 4th. Power to a power, multiply. Power to a power, multiply. I got 2 more over here. So if you have a power raised to a power, we can multiply the exponents. Power raised to a power, multiply the exponents. Hopefully that helped. Apologize about the bells. See you on the next one.